Hi guys, my name is Shubhang Garodia, Chemistry Master Teacher at Vedantu. Today we are going to talk about JEE Advanced 2020 Paper 1 and question number 11. Now, this question is an MCQ type, that is multiple correct type question guys. So be very careful. Now, it talks about hypochlorite, chlorate, perchlorate. So definitely this question is from P block chapter and group 17. Okay, now let's move ahead point by point. First says hypochlorite ion is the strongest conjugate base. Okay. Second talks about the molecular shape of chlorate ion. Okay. Third talks about hypochlorite and chlorate disproportionating. Okay. And fourth talks about hypochlorite acting as an oxidizing agent. Okay. So let's take them point by point. Now, if we want to talk about the basic strength of ClO minus, we'll have to talk about the acidic strength of their conjugate acids, right? So HOCl, HClO2, HClO3 and HClO4 are the conjugate acids of OCl minus, ClO2 minus, ClO3 minus and ClO4 minus. Now, we know that the acidic order is this, that is HClO4 is more acidic than HClO3 and so on. Why is that so? Because the conjugate base is more stable. This becomes the order of stability of conjugate base. Okay. Now, why is this order the stability of conjugate base? Two reasons. First reason is oxidation state. As oxidation state increases, the acidity increases. Okay. Now, second, also if you will see, resonance is increasing. As resonance increases, the stability of compound increases. Now, let's see how do we have more resonance. Let's compare chlorate and perchlorate. So, as you can see in this, O minus can resonate with two double bond O's, whereas here O minus can resonate with three double bond O's. So, more resonance, more stability, therefore more the acidity of the conjugate acid. Therefore, from here we can understand guys that OCl minus is the most stable conjugate base, right? And we can also say that because HOCl is the least acidic, then OCl minus is the most basic. It is the least stable conjugate base. Okay. Now, after this, this was the first point. Now let's go ahead to the second one where we talk about these shapes. So ClO minus ka shape is linear. Electrons cannot affect the shape of a linear molecule. If we talk about here, as you can see, chlorine is making 3 sigma bonds and 1 lone pair. So that's a total of 4. So the hybridization is sp3 and the geometry here of empty orbitals will be what? The geometry will be tetrahedral. Now, one orbital is occupied by lone pair and therefore the shape becomes trigonal pyramidal. So yes, lone pair does affect the shape of chlorate ion. Next, perchlorate ion mein you can see that there is 4 sigma bonds. That means sp3, that means geometry as well as the shape both are tetrahedral and therefore lone pair does not affect the shape of perchlorate at all. Okay. Now the next option was about disproportionation guys. So when ClO minus, that is chlorine in +1 disproportionate, it goes to higher as well as lower oxidation state, correct? Similarly, chlorate when it is in +5 will disproportionate, it will go to higher, that's +7 and lower, that's +1. So do we get same products? No, we don't get same products here. Next was about perchlorite HClO minus oxidizing sulfite. So yes, that's indeed correct. It's a strong oxidizing agent. So it oxidizes sulfite into sulfate, itself reducing to a negative oxidation state. Hence, guys, the correct answers are A, B, and D. Okay. So stay tuned for the next question, guys. Then thank you so much.